Okay, so today we have a really short topic, and this is from inorganic chemistry. This is group two. And in group two, there are things that you need to know from AS, like you need to know how they react with oxygen, with water, with dilute acids, how those oxides that they make, or hydroxides or carbonates that they have, how do those react with water and acid? How do their nitrates and carbonates decompose when you heat them? And what are some trends in their uh, compounds based on where the element is in the periodic table. Similarly, you need to talk about how the solubilities of their hydroxides and sulfates they change uh, or they vary down the group. Similarly, you need to know about the use of calcium hydroxide and calcium carbonate in fixing the pH of soil and all that for agriculture purposes. So all that is pretty straightforward. We know about their behaviors, and in AS, it's a really easy topic. You just have to memorize a lot. So what are we going to add in A2? The only thing we're going to add is कि हमने बोला कि their thermal decompositions is going to be there for nitrates and carbonates, or the solubility is going to vary from hydroxide and sulfates. तो वो क्यों होता है ऐसा? The reason for that. So in AS, we did not go into the reason. We just looked at what the trends were. The two main things: the thermal decomposition of nitrates and carbonates, and the second thing was solubility of sulfates and hydroxides. So these are the uh, two main things that we need to be able to answer for, like the reason why this happens. So let's get started. Let's talk about the solubility of sulfates first. The first thing, group 2 sulfates, they have the trend in their solubility is that down the group, the solubility decreases. So they become less soluble down the group. Okay, so this is something that we know of from AS. So that's the trend that we have. And why is that the case? We have already talked about enthalpy of solution, enthalpy of hydration, and we have talked about how lattice energy plays an important role there, how the enthalpy of hydration plays an important role there. And the delta H of solution depends on both of these. So delta H of solution is going to be dependent on lattice energy, which is something you have to supply, minus the hydration enthalpy, which is something that is released. And why is that? Because these are bonds broken and these are bonds made. Remember, lattice energy is not negative in itself. Oh, sorry, positive in itself. But lattice energy, because you have to supply it, that is the way it is going to be. And we're going to obviously take the positive value for that. Okay, that's the one that you have. So kind of like looking at this way, कि हमारे पास अगर इसकी मैं bond Haber cycle बनाऊं, so let's say magnesium sulfate. So magnesium sulfate, I have it in solid form, and I want to get magnesium ions in aqueous form and sulfate ions in aqueous form. So what will I need to do? I'll first obviously need to come up with a way to get the magnesium ions in the gaseous form and sulfate ions in the gaseous form. So this part where I get them in the gaseous form is delta H lattice. It is equal to the delta H lattice or lattice energy in the value, but उसका sign opposite होता है. Because remember, हमारे पास क्या है कि lattice energy is defined to be the energy released when gaseous ions come together. So it is this form of energy, that's lattice energy. So हम यहाँ पे उसके opposite जा रहे हैं. So I'll just put negative next to that. Okay. And then these are going to come together and they're going to form magnesium ion and sulfate ion. So ये मेरे पास यहाँ पर this energy is going to be obviously released in this case. So even though delta H hydration is going to be an exothermic thing here, I'm going to put a positive there because my cycle is like this. And this will give me the total delta H solution that I have, the delta H solution. So if you look at it, my bond Haber cycle has three important steps. One is I can just look at it this way, or I can look at it this way. And that is how I can just put them together. So you can look at this and be like, okay, that is how these things are going to be. Now, turns out that delta H solution uh, is an endothermic process here. Okay. And how this happens is that at the atomic level, you have ions. Sulfate तो इनमें सब में common है, but magnesium ion, calcium ion, barium ion, those ions are going to get bigger and bigger and bigger. So that's the first thing that we see. The cation's radius or size increases. Okay. Now, what this means is the charge density is going to decrease, right? So charge density. So that's my dog. Charge density decreases. And now the charge density has decreased. The lattice energy is going to obviously decrease. So lattice energy or delta H lattice energy or enthalpy decreases. Why? Because obviously you have bigger ions, they're not going to form really strong bonds. And at the same time, that same thing holds true for delta H hydration. That's also going to decrease because again, bigger ions don't form that strong of a bond. So what happens here? Thing is, delta H hydration decreases more. So the delta H hydration decreases more and the delta H lattice energy decreases less. And because of that, since the delta H hydration decreases more, the solubility is going to have to decrease. Okay. So here's what we can write. Both of these decrease because the cation size increases, both the energies decrease, but the hydration enthalpy decreases more. And so that makes it more endothermic. And so the solubility of sulfates decreases down the group. Okay. So that's what we will come up with. So delta H hydration decreases more, delta H solution becomes more endothermic. So the solubility decreases. You need to supply more energy from the outside of the environment to make them more soluble. Okay. So the question might be of 3 marks. One is what happens to the enthalpy change? So we'll say, what happens to the solubility? The solubility decreases. That's 1 mark. Then they ask you for reasons. So we say that the size of the cation increases, which is obviously going to affect both the lattice enthalpy and the hydration enthalpy. But hydration enthalpy decreases more. And that is why the effect is that the solubility becomes more endothermic, the delta H solution solubility decreases.
Sir,
Yep.
is delta H hydration also becoming more endothermic?
So delta H hydration जो है वो उसकी value जो है वो आपकी कम होती जाती है. Okay. So if it is exothermic, because bonds are being made, so वो values की कम होती जाती है. So we say it's becoming less negative or more positive. So yeah, that is what this is. You can interpret it in this way. So in the exam, in the book, they have used the words more endothermic and more exothermic, or less negative and more negative. Whatever makes more sense to you, आप उसको use कर लेना. If you're more comfortable with making it more endothermic वाली बात, तो use that. If you're more comfortable calling it less negative वाली बात, तो that's also right. The next thing, before we go into the next trend, here's something we need to understand. We need to know that ions can polarize other ions. And this is called polarization or polarizing effect. So ion polarization. So it is basically that when you have, it is the ability of one ion to attract electrons of the other. It could be attract or repel as well, and distort its shape. Because all anions, they have a cloud, and all cations have a cloud, and that cloud can have different charge density. और उस charge density की वजह से वो electrons को attract या repel करते हैं. Like an anion coming closer to another anion will distort it in a different way than a cation coming close to an anion, because cation उसकी electrons को pull करेगा towards itself and anion उसके electrons को repel करेगा away from itself. So that's distortion. And that whole distortion comes from the polarizing power or the ion polarization of this whole thing. So this is the distortion that you have. So for example, if I have a cation which is really small, so this is positive, and I have an anion which is really big. So what will happen is that if I bring this close to this, so it is going to pull, the cation is going to pull more on the electrons. So instead of being uniformly distributed around it, these electrons are going to be more pulled towards this side. So usse kya hoga ki my this thing is going to distort a little, and I'm going to get a shape which is more like कि इस तरह से more concentrated हो जाएगी towards this side. So I'm going to get a shape which is more like distorted towards this cation. Okay, so this is obviously going to increase based on the attraction from this and the relative sizes of these uh, ionic radius. So here's the thing. If you talk about the positive ions, the charge is the same in one group. So in group 2, it's positive 2. But the size increases down the group. So magnesium ion on one extreme and barium ion on the other extreme that we study. Of course, usme aur bhi hai, but we just focus on these. So magnesium to barium, the size increases, but the charge stays the same. And because of that, the what happens is that the charge density decreases. And because of charge density decreasing, the ion polarization or polarizing power, ion polarization, it decreases because obviously magnesium is a smaller charge, same charge but in a smaller volume, and barium is a much bigger volume but the same charge. So distribution uski different ho jati hai. Now here's what they do with other anions. They're going to pull
Sir,
them. Yep.
by less polarization, you mean कि like distortion कम होती है?
Yes, distortion कम होती है. मतलब अगर कार्बोनेट की शेप विद मैग्नीशियम बहुत ज्यादा चेंज होगी, but with calcium उतनी ज्यादा चेंज नहीं होगी. So with the carbonate, it's a big ion. So उसकी वजह से क्या होगा कि size of cation increases down the group, charge density decreases, the polarization of it decreases. Okay. Now here's the thing. Carbonate is special in the way that carbonate is technically, one way of looking at carbonate is that is oxide bound to a carbon dioxide. And the charge is actually on the oxide part. That's where the charge is coming from. Of course, वो बिल्कुल concentrated on one oxygen नहीं होता है, but that is how it is looked at. Like if you look at the structure of carbonate, तो carbonate में resonance structures होते हैं. Do you know that term?
I've
Do you know
heard
that
of the term. I don't really remember it, to be honest.
So here's what carbonate ion is like. So carbonate, you have 3 oxygens that have joined with it, but carbon needs to make 4 bonds, right? So इसमें क्या होता है कि carbonate इस तरह से हमारे पास 2 के साथ वो single bonds बना लेता है और तीसरे के साथ वो double bond बना लेता है. And that is one way we look at it. But technically ऐसा नहीं होता है. How does carbon decide कि इस oxygen के साथ double bond बनानी है और इनके साथ नहीं बनानी? How can it decide? They're all identical. Okay. So what it does is it has different uh, ions, different shapes or different structures which are all identical. Like इसके ऊपर अगर हो जाएगा और इस ऑक्सीजन के ऊपर ये ऐसे हो जाएगा, या इस ऑक्सीजन के साथ वो डबल बॉन्ड बना लेगा और इस ऑक्सीजन के साथ वो चार्जेस दे देगा. These are all the same ion and the same atoms there, right? We call these resonance structures. Resonant matlab कि the bond is kind of like it keeps on shifting. Okay. And that is what this is. We will see the shifting and the resonance structures in organic chemistry in A2 a lot. अब इससे हो क्या रहा है? The structure and bonding, if you measure it, you will see कि हमारे पास ये जो negative charge है ना, ये distribute हो जाता है. Because obviously this negative charge electron वो कभी इसके पास है, फिर कभी इसके पास है, कभी इसके पास है, तो वो technically इनके पास नहीं है. It is distributed on the whole ion. And distortion होने की वजह से वो क्या होता है कि वो किसी एक की तरफ ज्यादा पुल हो जाता है, और जब वो एक की तरफ पुल हो जाता है तो उसकी कार्बन के साथ जो बॉन्ड है वो वीक हो जाती है, पोलराइज कर दिया ना उसने उसको. और जब वो magnesium ion, let's say, इस वाले को pull कर रहा है. So the bond over here is going to be weakened. And that gives an option for the carbon to break this bond and make it with the other oxygen. If you observe and if you measure, X-ray crystallography is a technique through which we can actually measure the lengths of these bonds. If you actually do that, you will realize that all of these are of equal length. And that is weird. We would expect a double bond to be shorter than a single bond. But experimentally, we know that that's not the case. So the only option in which this is going to be is that the electrons are actually distributed on all the ions, and there are three ways of looking at where they are. But in any way, the moment you bring this carbonate close to a positive ion, it's going to pull on these oxygen more. So the electrons are going to be pulled more. So instead of being distributed completely, it's going to be pulled more towards one oxygen or oxide. Okay? So there's going to be a strong electrostatic attraction. और उससे क्या होगा कि अब वो जो magnesium ion आपने इसके साथ bond किया है ना, it's going to pull more on the electrons here. So obviously सारे electrons अब पूरी तरह distribute नहीं होंगे. They will be more towards this. So एक तरह से distortion हो जाएगी. Now this distortion, this ion polarization is stronger in smaller ions and stronger with ions with greater charge. दो ही चीजें कर सकते हैं ना, size and charge. So यहाँ पे charge same है in all the group 2, but the size increases down the group. Because of that, the distortion decreases क्योंकि वो उतनी strongly pull नहीं कर रहा है ना उनको. So उसकी वजह से क्या होता है कि this carbonate is easily able to break this bond and form a double bond with this oxygen. कि वो इसको छोड़ देता है ना, मतलब क्या करे वो. So this is going to be pulled more by this and less by this carbon. तो वो क्या कर सकता है? The bond breaks, and now this carbon gets the 2 electrons from here and forms a double bond here. The exact mechanism of this, we don't need to get into that. कि अच्छा किस तरह से the electrons are distributed or negative bond, -2 कैसे बन जाता है? Obviously, it's really easy to understand कि ये दोनों electrons इधर आ जाएंगे और ये दोनों electrons इधर आ जाएंगे and forms double bond. But they don't ask us about this. The important bit is that the more the polarization is, the easier it is to break this bond. And the easier it becomes to break this bond, the easier it is to get a carbon dioxide and let it go. Okay? So when you heat it, what happens is that how much you need to heat before that happens, before this bond breaks, depends on कि वो polarize हुआ कितना हुआ. So the smaller the ion, the positive ion, the higher the charge density on it, and the greater the polarization. So उसकी वजह से क्या होता है कि it breaks it easily. Okay. So अब क्या होता है? Magnesium will be able to pull on this oxygen much more strongly. So the bond will break बहुत कम energy. So we'll say the carbonate is not that stable. But barium, which is a much, much bigger ion, it won't be able to pull on this as strongly. और जब वो उतना ज़्यादा strongly उसको distort ही नहीं कर रहा है, तो उसकी वजह से वो bond भी उतनी जल्दी टूटेगी नहीं. So you need to supply a lot of energy before that breaks. So we say that the thermal stability increases. Why does it increase? Because it becomes easier to break. Sorry, it becomes difficult to break that bond between carbon and this oxygen, which is being pulled. And why is that? Because polarization is decreased. So down the group, size increases and charge density decreases because you have the same charge distributed on a greater volume. So polarization decreases. And when polarization decreases, you need more energy. So energy required to break the bond increases. Okay, clear?
Yes, sir. Bond कौन
Yeah.
सा break हो रहा है? Like which bond is becoming like harder to break?
Carbon and oxygen.
The double bond या फिर single bond?
Because the double bond is not entirely there. मतलब वो double bond है नहीं है. The electrons are distributed throughout the cloud. वो actually में
वो तो
किसी एक
मतलब
के
like
पास नहीं है.
oh ठीक है basically सब वो benzene वगैरह में होता है.
हाँ, exactly like that.
Oh, okay.
So that bond is broken, and if it is broken, तो वो carbon dioxide बनाता है और वो चले जाता है. Nitrates में भी ऐसे ही है. Nitrates में क्या है कि, and this whole answer is the same for nitrates as well, because nitrates में क्या है? You have a similar structure between nitrogen and the oxygens that are attached to it. Okay, so if you look at the structure of nitrate, तो उसमें भी हमारे पास बिल्कुल ऐसे ही structure है. You have resonance there, but it's just कि nitrogen के ऊपर एक positive charge भी होता है उसमें. कहाँ से आता है? We won't go into that. So nitrogen में ऐसे ये है. So obviously the electron is going to obviously show moving around and it's going to show a resonance. So by the way, it's a very interesting thing that nitrate and carbonate, they both have equal number of electrons. We call them isoelectronic. So nitrate and carbonate, not only are they isoelectronic, which is why they have the similar structure, but also कि उनके ऊपर दोनों में resonance भी होती है. So this is resonance. The electrons are distributed, and obviously a smaller cation will be able to pull on this more and distort the cloud and obviously break the bond between nitrogen and oxygen that's there. And in this case, it's going to break and it's going from NO2 because इन दोनों के साथ वो double bond बनाएगी and the positive and the negative charge is distributed और उस तरह से easily कर लेते हैं उसको. So there you go. You get so in nitrate, whatever metal nitrate you have, group 2 की बात कर रहा हूं, तो it's going to be like this. You get metal oxide because वो एक oxygen ले लेता है, and it gives off the NO2 and also oxygen, and you can balance it out. I think इसकी balancing इस तरह से थी. Yeah, and in the case of carbonate, you're going to get CO2 and the metal oxide. Okay. So in both of those cases, the reasoning is the same of why the nitrates become more stable down the group and carbonates become more stable down the group. Okay.
Yes, sir.
And hydroxide वगैरह की भी हमने solubility के ऊपर discussion कर ली है कि sulfates में क्या होता है और hydroxide. Again, the reasons are the same. In both of them, same thing applies, except कि hydroxide or sulfates में there's a difference. Okay, hydroxide is a much smaller ion and sulfate is a much bigger ion. So उसकी वजह से उनके trends जो है ना वो थोड़े से different होते हैं. So what happens to hydroxide down the group? Tell me.
Hydroxide. Wait, the solubility
Yeah, the solubility of hydroxides.
down the group, it decreases.
It increases. It is opposite. So down the group, hydroxides become more soluble. Why? Because again, down the group, lattice energy is decreasing. But at the same time, why is lattice energy decreasing? Because the cation radius increases. So the lattice energy decreases. But the hydration enthalpy, it is also going to decrease. But in this case, lattice energy decreases more. Why? Because hydroxide, इसकी reason exam में वो आपसे पूछता नहीं है, but मैं आपको वैसे बता देता हूँ. The actual reason of why they become more soluble down the group has to do with how the delta H hydration is going to be. So होता क्या है कि metal ion in the middle, it is able to form more dative bonds with water molecule if it has access to bigger orbitals or more orbitals. ठीक है. Up down the group, what happens is you have bigger ions, and with bigger ions, you have multiple periods that are available. And in those shells, you have more what you call dative bonds that the metal ion can make with the water molecules. Sulfate ke hote hue, that was a problem because sulfate is a hindrance. It's a much, much bigger ion. तो वो water को approach नहीं करने देता और water को वहां पे वो बनाने नहीं देता उस सांस. But in presence of hydroxide, which is a much smaller ion, it becomes really easy for water to make these bonds. And that way, the delta H hydration is not going to be that reduced compared to lattice enthalpy, और उसकी वजह से the solubility increases. It becomes, the delta H solution becomes more exothermic.